Today I will explain about automotive crash worthiness. So when you are riding on the vehicle, okay, so when some accidents or some unwanted incidents are happen, how safe you are inside the vehicle? That means the crash worthiness. It not only about the passengers, also the pedestrian safety. In order to ensure passengers or the pedestrian safety, okay, in and around the vehicle, there are number of systems they have been added, like seat belts, airbag systems, ABD, and EDS, and 360 view around view mirrors. Okay, and multiple systems they have been integrated in order to ensure the passenger or the pedestrian safety. Okay, so BIW structure is also one of the key parameter to ensure the vehicle safety. Apart from this, structures like these are the refinement systems. Apart from this refinement systems, there are multiple systems about BAW structure is one of the key parameter to safeguard the passengers and the pedestrian. Okay. In this session, I will explain how BAW structure ensure the vehicle safety or the passenger safety. Okay. So during the industrial evolutions happen, okay, they have been built multiple vehicles, especially on the Europe. Okay, so during 70s 80s, okay, they have been manufactured number of cars. Okay, then number of accidents also increase on the roads. Okay, so all the OEMs and the governments, okay, they have been integrated together, and they have been formed some organizations in order to ensure the passenger safety during accidents. Okay, so these organizations, this is called as a NCAP, that is New Car Assessment Program. Okay, so this new car assessment program, okay, they will conduct various tests against the vehicle and ensure the uh, safety of the passengers. Okay, so some of the famous NCAP I have been given here: Australian, Europe, Japan, Asian country, China, Korean, Latin America. Okay, each region or each countries they have their own NCAP. Okay, so now currently India until a couple of years back we have been followed global NCAP only. Now they have been introduced Bharat NCAP. Okay, during the previous crash test and all, we follow the global NCAP standards only. Okay, and US they have been follow separate organizations called FMVSS, that is the Federal Motor Vehicle Safety Standard. Okay, so these organizations, okay, conduct various crash tests against the vehicle and ensure that the vehicle or withstand the crash load at a certain conditions. Okay, those crash test scenario and conditions I will explain in the upcoming slide. So whenever you have any doubt, kindly stop me and ask whatever the questions you have, guys. Okay, as I mentioned, apart from these reframent systems called airbag and seat belts, okay, body structure, okay, is one of the key parameter to ensure the passenger's safety. Okay, as a BAW designer, okay, we have to ensure the BAW structure to withstand the crash load. Okay, how to check or how to ensure the that means the crash load withstandability. Okay, For that, we must has to understand the load paths. Okay, during the crash, okay, how the crash load distribute to each and every panel. Okay, I will show some of the examples. Okay, these are the load path. During the crash event, load will distribute to this area. Here you can see, okay, if the during the frontal crash, most of the load distribute from the front bumper beam to the front longitudinal member, that's the front S rail. Okay, so most of the load will be transferred. Okay, that will be transferred to the longitudinal member to the platform structure. Some of the load distributed to the sill structure. Okay, and some load here it will be distributed from the this one shotgun to A pillar area and the door structure during the frontal crash. Okay, we must has to ensure that the joineries we have to design properly, and we are selecting the right material for each and every part. Those ensure the crash regulations that I will explain with some this one case study so that you can understand even better. Okay, so if you have been defined the load path perfectly, then the BAW structure withstand the load. Okay, we have get minimum or no injury to the passengers or the driver. If we have been defined the load path poorly, that leads to more injury to the passenger or the occupants. Okay, in the BAW structure, we have to define the structure into two compartments, like a safety zone and a crumple zone. Okay. Here you can see this area, it should be a crumple zone area, and this should be where the passenger seats. That should be a safety zone area. Okay, why we have to design like this? Why these structures can't be so safety? Okay, why only the passenger area it is safe, and this frontal area why we make as a crumple zone? Okay, the reason is, okay, if we have been make this structure so rigid, okay, during the frontal crash, okay, so this structure, okay, will not absorb any energy. Instead of that, it transfer the energy to the next compartment. In the next compartment, the passenger and the occupants are uh, inside. Okay, if we transfer the load 100% load to the next compartment, then those load completely transfer to the passengers, that lead into high injury. That is the reason these structures we have to make so soft or so crumble, then it crush, it absorbs the energy rather than transfer the energy. So 50-60% of the energy absorbs here only, so that the passenger will get minimum impact. That is the reason. So this area we have to design very weak structure. So this, okay, this is medium strength material. This is high strength. This is advanced high strength. These are ultra high strength material. The gray materials are this one, mild steels. Okay, this area and all mild steel. So this safer zone area, okay, we must has to design with the high strength material. So this has to crumple and absorbs the energy here. Okay, so that is the reason. Okay, this area we have to design with advanced or ultra high strength material, whereas the front and the rear zone we have to design with the mild steel material, that is a low strength material. Okay, is that clear? Hello guys,
Sir.
is it clear?
Sir. Yes, sir.
Okay, so this is some synopsis that how we ensure the vehicle safety. That is okay. So the load path area, so it has to be designed like the front structure should be crumple zone to absorb the energy, same as the rear structure. For this front structure and the rear structures, major requirement is not high strength, that is high stiffness. Okay, around the cabin area, that is the passenger occupant area, we must have to design with the high strength material, the floor reinforcement, the door side structure, the roof structures. Okay, all this we have to design with high strength material to ensure the passenger safety.